All right, we've covered a lot of ground, easily a dozen performance rules.
Yeah, to be honest, it's a bit overwhelming. There is a lot to keep in mind.
I think I can help you with that. There's a lot of different rules, but really, there are 3 buckets into which we can place most of them.
Huh? So what do you mean?
Well, let's take a look. First, we talked about minifying, compression, and caching. All 3 techniques apply to HTML, CSS, and JavaScript. Next, we know that some resources, namely CSS, will block rendering. To optimize this, we talked about 2 strategies. Use media queries on link to unblock rendering, and inline CSS. Finally, we also saw that JavaScript blocks the document parser, which is something we want to avoid. To fix that, we can defer JavaScript execution or use the async attribute on the script tag. So, looking at these, can you spot some patterns?
Let's see. Minify, compress, cache, and minimizing the amount of HTML, CSS, and JavaScript is all about reducing the amount of data we have to send down the wire, right?
Spot on. That's the first bucket. Minimize the number of bytes. The fewer bytes we need to download, the faster the browser can get the data and start processing to render the page. Any other patterns?
Okay, so this one and this one are all about removing files from the critical rendering path. For CSS, there's the media query stuff, and for JavaScript, we have the async tag.
Exactly. There are many cases where we need CSS and JavaScript, but they really shouldn't block rendering of the page. Things like print style sheets and analytics JavaScript code are both great examples. Our second bucket is to reduce the number of critical resources.
Right. Not all resources are critical, so I guess we should pay close attention to CSS and JavaScript in particular. What's the third bucket? I don't see anything left here.
Right. The last one is to shorten the critical rendering path length.
Wait, what do you mean by length?
Good question. Let's work through some hands-on examples. Let's construct the critical rendering path for our Hello World page here. At time 0, we request the HTML. Once the response arrives, sometime later at time 1, we parse the HTML and construct a DOM, and then we render the page to the screen. Note that there's no CSS or JavaScript, so as soon as we have the DOM, we can render the page. We do have an image in this page, but it doesn't block the critical rendering path.
That seems pretty straightforward.
Yeah, fair enough. We'll make it more interesting in a second, but first, let's analyze the first page against our 3 buckets. First, how many critical path resources do we have here?
Well, there's only one HTML file, and obviously we need that to render the page, so just one?
Yep, we have 1 critical resource on this page. Now, how many critical bytes do we have here?
Well, the HTML is 5 kilobytes, so 5 kilobytes.
Right again. We have 5 kilobytes. Now, the last one. In the best case, how many round trips between the browser and the server do we need to render this page?
I'm guessing also 1. We send the request to the server and we get the response. And I think with that we're good.
You're right this time. If the HTML file is small, then we only need 1 round trip to fetch all the data. As a result, the best case critical path length is also 1.
I remember PageSpeed Insights said that my page should ideally be under 14 kilobytes. Is this why?
Yes, exactly. And of course, if the page is larger, the page will still render, but if the file is large, it'll take more round trips to fetch the data. And this is pretty low-level stuff, but it can make a big difference in how quickly the page takes to render. So check the instructor notes if you want to learn more.
Wait, did you write a book on this?
Actually, yes I did, and it's available online and it's free, so if you're curious about this topic, you can learn more about it. Check the instructor notes.
Cool, yeah, will do.